Alright, 10 reasons the galaxy is trying to kill you. Number 10. Sagittarius. A star. You look toward the bright band of the Milky Way and you are looking toward this darkness. It is the gravitational anchor for 100 billion stars. It crushes the mass of 4 million suns into a space smaller than our solar system, distorting everything around it. The blackness itself is completely invisible. We only see the chaos immediately surrounding the event horizon. Astronomers tracked fast-moving stars and watched one swing by like a stone on a string. From those orbits, they proved an immense mass hides inside a tiny radius. For decades, it seemed completely dormant, but new observations show it frequently wakes up. Light echoes off nearby clouds reveal that a few hundred to 1,000 years ago, it flared intensely. So telescopes such as Chandra Webb and the Event Horizon Telescope keep catching sudden chatter. Those flares mean the core can flip from sleepy to savage on human timescales. The center of our galaxy is not a quiet monument. It is a very active threat. You measure this monster by watching motion, not light. Astronomers Andrea Ghez and Reinhard Genzel turned that threat into a ruler when they tracked stars whipping around a central point. One star called S2 raced on an incredibly tight orbit, leaving no room for alternative theories. Their teams followed the stars for decades and shared a Nobel Prize for the discovery. In 2022, the Event Horizon Telescope captured a ring of glowing gas around a dark silhouette matching theoretical predictions perfectly. Webb Chandra X Rhythm filled in the wider neighborhood. Webb showed turbulent firework like flares, while XRISM read light echoes, proving recent catastrophic outbursts. The core is mostly quiet today, but it is definitely not asleep. Small clouds and wandering stars occasionally slip inward and get torn apart. The resulting eruptions do far more than just flash across the sky. They dump immense energy into the surrounding space, forcing the entire inner galaxy to reshape itself. Number 9. Magnetic filaments. Pictures of the inner galaxy often show bizarre strings of light stabbing out into space. They look like glowing scratches on a photograph, but they are massive physical structures. These are long, thin threads of charged particles racing at nearly the speed of light, trapped inside intense magnetic fields. So hundreds of them stand vertically from the galactic plane like the strings of a colossal harp. They can stretch for over 150 light years. Radio arrays such as Meerkat mapped nearly 1,000 of these strands, revealing a highly organized pattern that nobody expected. The filaments glow in radio waves because electrons spiraling along the fields emit synchrotron radiation. This proves the structures are incredibly energetic and ancient. The origin of these ordered fields remains a mystery. One leading hypothesis suggests a past jet from the supermassive black hole collided with surrounding gas-wrapping magnetic fields around dense obstacles. Alternatively, violent turbulence carved them out locally. These are vast highways for cosmic rays and the fossilized fingerprints of past eruptions. These filaments operate as highly active magnetized wires guiding particles across the entire central region. Radio spectra show incredibly varied slopes, proving the strands possess different physical properties depending on their location. Some act as particle accelerators, boosting cosmic rays to extreme energies. Horizontal filaments run parallel to the galactic plane, physically interacting with dense molecular clouds. Vertical strands point straight away from the plane, suggesting a focused violent outflow from the deepest interior. Meerkat and other arrays gave us the map, while polarization data proves the magnetic fields actually strengthen along the length of the structures. Models suggest powerful winds from historical eruptions stretched weak background fields into these massive, organized shapes. If true, these strands preserve the physical scars of chaotic events from millions of years ago. They actively distribute energy throughout the region, altering gas temperatures and dictating where new stars are allowed to form. Following these glowing trails inward leads directly to other bizarre objects orbiting deep within the central abyss. Number 8. G objects. When astronomers first spotted them, they appeared to be simple gas clouds. Upon closer inspection, they behave remarkably like stars. They remain tightly compact as they orbit deeply into the center, stretching only slightly when they swing closest to the black hole. The first two anomalies were discovered in 2005 and 2012. Keck and the Very Large Telescope later identified several more leading researchers to label them G1 through G6. A normal gas cloud would have been completely shredded by tidal forces at that range. The survival of these objects proves there is massive structure inside. Spectra and orbital dynamics reveal a very dense stellar core hiding inside a massive dusty envelope. One prominent theory suggests binary stars collided and merged, forming a bloated, cocooned remnant. Instruments like Eris using adaptive optics confirm they act like obscured stars. The density of the inner galaxy forces stars into constant near misses and collisions, resulting in bizarre stellar hybrids that defy normal classification. Observing these G objects approach periapsis is baffling. The extreme gravity of the central black hole stretches their outer envelopes, peeling the dust like taffy, while the dense internal core holds the primary structure together. Spectra reveal prominent absorption lines and stellar winds characteristic of massive stars. Adaptive optics on Keck and Eris at the Very Large Telescope constantly peer through the thick veils seeking the solid cores. The environment near the supermassive black hole is so packed with stars that binary pairs are frequently forced to merge. The resulting collision throws off an immense shroud of dust. The newly merged star inside anchors the chaotic mess. The dusty envelope disguises the object as a cloud, allowing it to slip through extreme tidal zones. These survivors eventually shed material directly into the supermassive black hole, fueling random outbursts. They secretly seed the surrounding space with heavy elements and unpredictable fuel parcels. But they are not the only things hiding in the dust. A massive invisible population of predators shares this exact space. Number 7. Thousands of small black holes. The extreme gravity of the central supermassive black hole acts like a cosmic drain, slowly pulling in heavy remnants from across the inner galaxy. When massive stars die and collapse into black holes, they gradually sink toward the center. Over millions of years, gravity herds them into a terrifyingly dense concentration. X-ray surveys using the Chandra telescope found a dozen bright candidates packed into a tiny volume around the central region. Those are merely the ones actively feeding. Theoretical models prove the true population likely numbers between 10 and 20,000. Most remain entirely silent until they violently rip gas from a passing companion star. We only detect them when they feed. A sudden X-ray flare or a changing radio source briefly flags their invisible presence. Even when silent, their combined mass heavily stirs the neighborhood. They physically scatter stars and harden binaries, raising the odds of collisions. The center of our galaxy is not ruled by one monster alone. It is surrounded by thousands of smaller, invisible assassins. Finding an isolated black hole is incredibly difficult because they do not announce themselves. They simply drift through the darkness until they collide with another compact object or tear apart a wandering star. When that happens, the entire galaxy notices. A brilliant X-ray flare or a sudden burst of gravitational waves betrays their exact location. Deep radio surveys actively hunt for the loudest ones, but mass segregation guarantees that thousands more remain totally silent. As heavy stellar remnants constantly drag inward, they pile up in the central parsec. Their collective gravity severely distorts stellar orbits. They violently kick stars out of the region and trigger high-speed collisions that produce gravitational waves. In a volume of space filled with thousands of invisible gravity wells, even a tiny orbital shift can cascade into total chaos. These unseen remnants dictate the fate of almost every nearby star, and the destruction does not stop with individual stars. Whole clusters are currently being torn to pieces. Number 6. Dense star clusters being ripped apart. Globular clusters are ancient spherical cities packing hundreds of thousands of stars into tight spaces. But when their orbits carry them too close to the galactic core, they face pure gravitational violence. Checked. The sheer mass of the center pulls harder on the leading edge of the cluster than the trailing edge, stretching the entire system until it physically breaks. Astronomers watching the cluster known as NGC 6569 caught it slowly bleeding its members into the void. Using the Anglo-Australian telescope, the MW Best survey mapped the exact escape routes of these doomed stars. This process is called tidal stripping. Over millions of years, entire neighborhoods of stars dissolve into long, thin streams. These streams act like the shattered bones of dead clusters, slowly building the central bulge while disguising its original history. The center continually feeds on these stolen stars, pulling old relics into its chaotic orbit. This wanderlust often brings them dangerously close to the supermassive black hole. This gravitational theft happens with agonizing slowness. Tidal stripping physically peels stars away from the dying cluster one by one. Observers analyzing data from the MW Best survey took detailed spectra of 303 stars. Their mapped motions proved that NGC 6569 is bleeding mass at a terrifyingly consistent rate. The research team estimates the cluster loses the equivalent of 1 to 1.5 suns every million years. As these escape stars drift freely into the galactic bulge, they completely blur the chemical fingerprints of the region. They also carry dangerous compact remnants and tight binary systems along with them. The center is constantly fed by these stolen bodies, ensuring a steady trickle of fresh fuel. Shots, a wandering blue straggler or a heavy dead star can tumble inward and trigger a sudden catastrophic collision with zero warning. But not all the danger comes from falling stars. Some of the weirdest threats are massive clouds of frozen gas. Number 5. The Brick Molecular Cloud. Most dark clouds full of ice are completely dormant, but the brick defies logic. The James Webb Telescope peered through the dust and found vast amounts of carbon monoxide locked in ice across the entire structure. This completely contradicts established models because carbon monoxide ice usually signals extremely cold gas ready to fragment and form stars. Yet the gas inside the brick measures significantly warmer than comparable clouds. ALMA and other major observatories easily found infant stars in nearby clouds, but the brick remains totally barren. It holds all the necessary raw ingredients for starbirth, but stubbornly refuses to form them. This anomaly breaks the fundamental rules astronomers use to predict stellar formation. Furthermore, if massive amounts of ice can hide invisibly inside these clouds, we are drastically undercounting the available fuel sitting near the galactic center. This cloud acts like a hidden explosive reservoir hoarding mass that could eventually be dumped directly into the black hole. The interior of the brick presents an impossible contradiction. Carbon monoxide normally freezes solid at around 20 Kelvin, but probes prove the brick measures closer to 60 Kelvin. Astronomers are struggling to explain this intense thermal mismatch. Several extreme forces could be responsible. High-energy cosmic rays and X-rays constantly bombard and heat the gas from the outside. Simultaneously, violent turbulence and tidal shear aggressively stir the cloud, preventing dense pockets from collapsing. Strong magnetic fields might be suspending the gas like an invisible scaffold, while ice remains stubbornly trapped on dust grains. Because ice frozen onto grains is completely invisible to standard gas surveys, we might be missing a massive percentage of the fuel hiding in this region. If a sudden shockwave or collision finally triggers a collapse, this icy warehouse could dump immense material inward. The brick sits quietly today, but it is potentially explosive tomorrow, and we know exactly what happens when the center explodes. Number 4. The Fermi Bubbles. In 2010, the Fermi Gamma Ray Space Telescope found something that should not exist. two colossal lobes of gamma-ray light balloon aggressively above and below the center of our galaxy. Each one stretches about 25,000 light-years. Together they span a distance equal to half the width of the Milky Way itself. The energy physically locked inside them rivals the simultaneous output of 100,000 supernovae. Something at the galactic core exploded outward with a fury astronomers can barely model. The leading explanation points to a violent outburst from Sagittarius A star roughly 2.6 million years ago. For about 100,000 years, the center blazed and drove superheated gas into the halo at tremendous speed. So the Rosetta X-ray telescope later found an even larger set of bubbles wrapped around the first. This completely confirmed the eruption was not a simple flicker. It was sustained and deeply catastrophic. Our galaxy carries the physical scars of a tantrum thrown by its own supermassive core. Those massive scars are still glowing brightly. The outer bubbles found by Rosetta extend even further. They reach roughly 45,000 light-years above and below the plane, glowing violently in X-rays. A massive shock wave is still pushing outward through the thin gas of the galactic halo, continuously gathering and heating everything it touches. Scientists strongly debate the original trigger. One camp argues Sagittarius, a star, woke up and launched jets of energy like a quasar in miniature. Another camp suggests a burst of intense star formation near the center drove winds powerful enough to inflate the massive lobes. Either answer is deeply unsettling because both require an engine at the core capable of reshaping the galaxy on a grand scale. The timeline makes it even more real. The eruption happened roughly 2.6 million years ago. Early human ancestors were already walking in East Africa when the center of the Milky Way completely detonated. The high-energy light from that tantrum is still reaching us today. This proves the galaxy is definitely not calm. Next, we look for something even stranger hiding near the center, holding the most powerful magnetic field in the universe. Number 3, the galactic center magnetar. Picture a dead star with a magnetic field so violent it could wipe every hard drive on Earth from the distance of the moon. Astronomers found exactly that monster lurking a mere fraction of a light year from the supermassive black hole. In 2013, telescopes such as Swift and NuSTAR caught a sudden burst of X-rays flashing from the galactic core. They looked toward the center and found a crushed stellar core spinning wildly. It is a magnetar. Its magnetic field is 100 trillion times stronger than our planet's. Most magnetars are totally silent in radio waves, but this one screams. It blasts intense radio pulses into the void every 3.76 seconds. The Green Bank telescope and other arrays caught those flashes cutting through the dust. So finding a magnetic beast this powerful orbiting so terrifyingly close to the central black hole changes everything. It proves the core does not just destroy stars, it leaves their tortured remains behind to haunt the darkness. That screaming dead star is more than just a local terror. It is a flashlight piercing the deepest fog in the galaxy. As its radio pulses travel toward us, they must pass through the thick magnetic gas surrounding the supermassive black hole. That journey twists the light. By measuring exactly how the pulses bend, astronomers can map the invisible magnetic fields wrapping around the central darkness. They discovered the magnetic field near the black hole is incredibly strong and highly ordered. That organized force might be what controls how the black hole feeds. But this magnetar holds an even darker implication. Some scientists believe violent flashes from objects like this might be the source of mysterious fast radio bursts striking our galaxy from deep space. We have a cosmic engine capable of unimaginable violence sitting in our own galactic backyard. The center of the Milky Way is crowded with these extreme dead stars. The fastest among them might hold the key to testing gravity itself. Number 2, high-speed stars and the millisecond signals. You measure extreme gravity by watching motion. Some stars race so fast they become precision tools. The S2 star swung dangerously close and proved a compact mass of about 4 million suns hides inside. Telescopes such as Gravity and Gaia traced those orbits for decades, effectively turning wandering stars into rulers. Now picture a clock with millisecond precision sitting deep inside that exact gravity well. Deep radio surveys and Breakthrough Listen have flagged a candidate pulsar near the center, spinning at about 8 milliseconds. If confirmed, it would be a nature-made stopwatch orbiting the central mass. Each precise tick would be physically bent and delayed by extreme gravity. Timing those pulses would reveal tiny orbital shifts that severely test Einstein in the strongest field we can reach. The clock could also sense hidden companions or tiny tugs from the massive swarm of compact objects we cannot see. Best of all, a pulsar near the core could definitively prove whether spacetime ends at an event horizon or at something much stranger. Finding that tick would change everything in physics. Sweet. But we must also consider the strange stars being born inside this chaos. You already heard how S2 proved something enormous sits at the center. A millisecond pulsar would do the rest. Pulsars are incredible nature-made clocks. They spin rapidly and beam radio light with complete machine-like regularity. Drop one deep into the gravity well, and every single tick becomes a massive physical test. Timing a pulse is simple in idea and incredibly brutal in practice. Each arrival can be significantly delayed by warped space. The pulse can be stretched by gravitational redshift and nudged slightly by passing compact objects. The precise pattern of these delays tells us exactly about the mass, the spin, and the geometry of spacetime itself. Breakthrough. Listen and deep radio surveys actively flagged a candidate spinning at about 8.19 milliseconds. If that signal is a true pulsar and it orbits close, then radio timing arrays will read a stream of tiny anomalies. Gravity and Gaia currently map the stars while the Event Horizon Telescope directly images the black hole silhouette. Together they would turn one spinning star into a scalpel for gravity. One confirmed clock could prove whether spacetime actually ends at an event horizon or if something fundamentally different hides there. Find that tick and physics will be forced to answer. Next, we meet massive stars that simply should not exist. Number 1. The impossible young stars. Some stars near the center should not exist. The tidal forces around a mass of 4 million suns are savage enough to shred any gas cloud before it can collapse and form a star. Yet astronomers found them. The S cluster is a group of young hot stars racing around Sagittarius A star on wild orbits. They are only a few million years old. In cosmic terms, they were born yesterday. Astronomers name this the paradox of youth. The environment is too violent for stellar birth, but the stars are there, bright and undeniable. Keck and Gravity tracked their paths and confirmed their ages. Then in 2023 came something even stranger. A team discovered X3 A baby star only tens of thousands of years old sitting terrifyingly close to the black hole. It is not a relic. It is practically a newborn. So, one idea says these stars formed further out in a cold shielded dust ring and then spiraled inward. Another says violent binary encounters with the black hole captured them. Either way, the center is making or stealing young stars in a place where birth should be forbidden. The paradox actually cuts deeper. Observations definitively show these young stars are almost always completely alone. The black hole literally rips apart incoming binary systems, swallowing one partner completely and aggressively, flinging the survivor into a tight orbit. The lone survivor looks young hot and mathematically impossible. Now step back and look at the full picture. A supermassive anchor of 4 million suns sits directly at the core. Giant magnetic filaments thread intense energy outward. Bizarre dusty G objects hide fully merged stars. The brick silently hoards vast amounts of frozen fuel. Thousands of smaller black holes constantly prowl unseen. Dying clusters permanently leak stolen stars inward. The Fermi Bubbles prove the center once erupted with the force of 100,000 simultaneous supernovae. A wildly violent magnetar flashes X-rays in the absolute dark. High-speed runaway stars and a possible millisecond pulsar promise to heavily test the limits of gravity itself. And now we confirm massive stars are somehow born or stolen in an environment where birth should be impossible. Meerkat Web, Chandra Keck. Gravity and the Event Horizon Telescope meticulously mapped these pieces. XRISM and Gaia added precise timing and motion. The center of the Milky Way is not a quiet, empty void. It is an intensely dynamic and highly dangerous thermodynamic engine. If you appreciate a deep, factual look at the actual physics driving our universe, subscribe to the channel. We will continue exploring the darkest, most complex mechanisms operating in the cosmos. Thank you for watching.